This is the GIST Council. I'm Dave McComb from Semantic Arts, and today, November 5th, we're going to talk about entity and identity resolution. And what the reason we're going to talk about this is I want to have a discussion. Do we need ontological support for this? And if we do, what should we consider? And should we put it in GIST, or should it be somewhere else? There's some interesting open questions. But first, I want to talk about just what this topic even is. I'm going to have a little bit of a primer on it, just so everybody's at the same place and we have some shared language. And then we're finally going to get to an open discussion about this. So what are we talking about here? It's, in our terms, if you have information in your system, how do you know whether it's referring to the same referent? And I went looking for about 15 minutes, couldn't find. We used to have this nice little picture in our old DBBO class of a horse kicking someone, and the horse had a couple different names, Buttercup or something else. And the point there was you get kicked by the horse, not but the label Buttercup or any other identifier. The thing in the real world that deals with it is the referent, is what all this information is referring to. So with entity and identity resolution, we're trying to figure out whether and when the information in our system is referring to the same referent. I saw this great little tutorial. I got some of my ideas from this. So it's attributed down there at the bottom, but I thought one of the funniest slides, they said, ironically, entity resolution has many duplicate names. And I think some of the ones we hear the most are things like deduplication. All these people that have mailing lists and stuff are constantly trying to figure that out. Or some people call it record linking and merge and purge and householding or household matching. All those are all about trying to figure out, and that's just one isolated example of this whole field. But you'll find it called all of these things and many more. I decided to go with entity identity resolution. It seems to describe what we're doing. We're trying to establish whether we have identifiers in our system. We have URIs, and they are identifying specific entities. We still, in the information space, we think there's a type of thing there, but what we really want to do is, when do we have more than one identifier for the same thing? And so that would just be identity resolution. But it seems the deeper you get into this, your strategy is going to change a lot depending on what sort of entity you're looking at. And we're going to talk a bit about that as we get into it. It's funny. I was doing some research for this. That when people are 100% in the data world, they get hilariously confused. And by having kind of one foot in the real world and one foot in the data world, sorting this stuff out seems to be a lot easier. What are we going to focus on? Classically, people are trying to figure out whether two people are the same person or not. Information about people, customers, workers, etc., or whether two organizations, which is quite a different problem. It sounds the same superficially. Whether two places are the same, whether you're talking about specific products, physical things, or whether you're talking about product specifications. Interestingly, we got Dr. Sam here. This will be fun. And occasionally, and some interesting cases for documents and transactions. Also, later in the presentation, I came across a few other semi-obscure things. I mean, you rarely need to do entity resolution for, taxonomic distinctions. You just map the, I don't know, almost nobody talks about some of these other categories. So what I want to do is talk about the general process of entity identity resolution, then come back to these and say, how is it different for each of those? And then finally circle back and talk about what does it look like in an what sort of ontology support might we want? And by the way, my take is that authentication is a sub domain to identity resolution. In other words, what is typically going on when you authenticate someone is trying to figure out whether the referent, the person who's logging in right now and trying to do something, is the same as the one that set up an account or whatever it was that occurred earlier. They have different strategies, but in many ways, it's kind of the same problem. There's three variations on this, so the use cases end up being quite a bit different. Sometimes sometimes the referent is interested in collapsing the multiple representation you have of them. You go into the doctor's office and, oh, Mr. Jones, you are the same Mr. Jones who was here last year. We took out your appendix, right? Oh my God, no, that's not me. Or yes, that is. Nobody's gonna try and be deceptive there. There are things where there's not necessarily anybody in the loop who even cares or say, oh yeah, that's me. Like trying to figure out whether two buildings or two addresses are really the same. It's kind of an indifferent thing. And then there's a lot of use cases where we're trying to do identity resolution with people who don't want their identities revealed. So we got three different variations on it. There's three different strategies, but they reuse a lot of the same mechanism, or at least we hope. You just dial the rules up differently. How we do it right now when we go into clients, we're not doing a lot of entity identity resolution, but I think we are going to be doing a lot more soon because we're mostly relating on curated data. Companies spend a lot of time making sure they don't have two employee master files for the same employee. There's just a whole lot of manual stuff going on and data quality and all that. But once you get past the stuff that the enterprise has curated a lot, this is going to show up more and more. It already shows up a bit, and we have kind of ad hoc approaches to it, but this is more about where are we really going to go with this. This is a classic. I just cut and paste this from a website somewhere. This is actually far cleaner than most of the examples because usually the telephones would be in a different format or the abbreviations would all be different, but they were using this to explore how the same person, may spell their name differently, different nicknames, all that kind of stuff. This is the classic and missing data. Here's what we're talking about. How many people are there in this little database here? And I don't know the answer. This is all those things you have to deal with. So typically, there are workflows for these. There are products, there are approaches, there are open source toolkits. There's all kinds of stuff to do this, but most of them go something like this. One of the first things, and we've done this a lot dealing with spreadsheets. You have to get rid of leading spaces and non readable characters, things like that, and then get the phone numbers and dates and stuff into one structure. Make sure the dates are either internally represented dates, or if they are strings, that they're all month, day, or they're all day, whatever it is, but some kind of canonical structure. So get started with that. Then in a few cases, we haven't come across this, but you'll have information of mixed languages or mixed character codes. You may have, if you have addresses, some of them in English and some of them in Chinese, and they might be the same address. You have to deal with that. Many identifiers, though, are not textual language. They're just identifiers, phone numbers, even names are typically not in a language per se. A lot of times there's abbreviations in the information you want to use to do this resolution. Things like RD for road, but also company names, things like that. We're going to make it easier to figure out whether two things are the same thing or not. there's very often spelling and typos and extra letters, and there's all kinds of techniques to get that resolved. And then a lot of times it helps to fill the thing up with synonyms and aliases, the names, Rob, Bob, Bobby, all that kind of stuff. And also names have this characteristic that sometimes you have to try it the other way around. Maybe this was Thomas, comma, Grant, or Grant, Grant, comma, Thomas, etc. So that's a typical first bit of a workflow. And I'm just going to refer to this whole thing as, in our world, as literal normalization. In other words, take the literals that we have in an ontology and get them into some format that's going to make it easier to compare them. And this is typically for either one cell, one data type property in our world, or a small number of them that are very closely related, like first name, last name, middle name, or middle initial, or whatever. And in some cases, that's enough. You can do your resolution with just this. However, that's not the interesting case. The interesting case is where it takes many literals attached to one identifier and several others attached to another to look at that and say, are they the same or not the same? So that's where it gets interesting. What combination of literals is good enough that we would say, let's call these equivalent. So let's go back, just kind of some examples of how people think about that question for each of these types of entities. A lot of literature. I read some white papers and stuff about, with people, historically they were looking at their so-called identity attributes, your name and date of birth and all that kind of stuff. Turns out Simon, my old partner, did a bunch of work with the Los Angeles Police Department, or Sheriff's Department, I guess it was. And for them, it was tattoos. They were pretty convinced that tattoos were the way you identified people who didn't want to be identified, because they're hard to get rid of and pretty distinctive. You just have to have a way of describing them. But what some of the new activity is use some other things besides just your identity, like what you did, or especially what you're related to. Some of these things are harder to fake. If you can figure out who employs somebody or what groups they belong to, independent of the person, that those are very often better clues as to somebody's identity. In authentication, as we talked to earlier, they kind of drill it down to what you know, what you have, and who you are, as different sort of clues as to are you the same person that we saw last time we dealt with you. What I think is missing from most of this stuff, it's sort of curious, I didn't come across it as I was doing the research, because in fact we did a little bit of this at LexisNexis way back when, and it was very fascinating to me. But when you think about just trying to match somebody's name and trying to figure out whether you have that person, I've done some web searches. This is my wife's name. Turns out, near as I can tell, that name is globally unique. You type it into a browser, you get about 2 pages of information. Every single one of them refers to her. And knowing that, if you were trying to do some resolution, you found that name, you go, yeah, pretty high chance that is the same other person I have in my database with that same name. Whereas you find James Smith, we happen to know in the real world that there are hundreds of thousands of James Smiths, and the odds that this one is the same as the one you're dealing with are pretty low. Even something you'd think is not that common, Dave McComb, I've searched this many times, you typically get the lead singer of the Triffids, or for some reason, there's a whole bunch of county commissioners in various states throughout the Midwest who all named Dave McComb, and somebody who wrote books about battleships in World War II. And then, I went looking for what are the most common, not just common first name and common last name, but the most common combinations. And some of these, are close to useless if you actually are trying to connect two people up. They're also, of all the types you have here, the ones most likely to not want to be identified. It's not always true. In fact, most times not true, but you have to consider that when you're dealing with people. So organizations have a different issue, and that is, person is just, there's just a person. There's not, a subdivision. There's not a department of Dave McComb or a subunit or anything like that. And the existence, at least of a legally representable organization, is they have these identifiers, very often assigned by government agencies. But the first problem for most systems is what we think of as an outsider of an organization. You talk, well, we're doing business with Goldman Sachs or Ford Motor Company, is actually a bag of legal entities that might be hundreds or sometimes thousands. And you're trying to sort out how do you identify them and all that kind of stuff. And it's sort of subjective. You may decide that I'm going to treat all of the LEIs of Goldman Sachs as an organization because they treat themselves that way. They just happen to be legally incorporated all over the place and have many subsidiaries and stuff. The other thing that's different between organizations and people is this idea of ownership. If a company owns another company, we very often say that's now one company. And sometimes they don't own it outright. They own controlling interest. These things change over time. So the whole identity question is all caught up in ownership and shares and things like that. And then just to make it even more complicated, many of the data sources we have to rely on conflate a location with an organization. So Dun & Bradstreet, for instance, calls these things establishments. They sort of refer to them as organizations. They will, if there are many Starbucks in a town, those are different establishments. They may or may not have the same ownership. If it's a McDonald's, they probably have different ownership. If it's a Starbucks, it's probably the same ownership. So a lot of complicated issues with that on organizations. When we talk about places, 90% of this are addresses, either a delivery address or a mail address. And of course, 90% of all addresses are both, but post office boxes are one. And there's certain places you can deliver things that are not necessarily postal addresses. A lot of this can be done with address standardization. You just send in what they fix it and send it back. What tends to be the problem, most of the stuff we look at is missing implied information. Here's a list of addresses. Well, because they're in this file, that they're all from a given city or a given state, but inside the file, the information's missing, it's just implied. And most people don't get too confused, even though there are multiple identifiers for countries. It's that one is not super hard to resolve. There's a little bit of work there, but that's not the difficult case. For a specific physical product, like a car, there's one the problem is there's more than one identifier. Like a car, the real one is its VIN, but 99% of the time you don't have access to the VIN. Maybe you've got a license plate, so we have to associate the license plate to the car because that changes over time and the VIN doesn't. You get the same problem with plant and equipment. Somebody designs something that has an identifier, and that's how they refer to it for a while, and then they put tag numbers on it, serial numbers, or part locations, all that kind of stuff. And you have and some of their record keeping is using one or the other of those. So the resolution is to figure out which ones are referring to the same thing. There's really mostly two use cases here: things that move a lot and things that don't. Things that don't, you probably want to rely on the actual physical location. Where is this heat exchanger in this plant, in this flow? Pretty good chance anything that's in that position is the same heat exchanger, whereas cars, knowing where they are doesn't help you all that much. A product specification, though, an SKU is a different issue, because saying that two specifications are the same, they're only literally the same if they're identical. But what really happens in the world is you have specifications for products that are interchangeable. And so as far as your, if any product, you have product numbers A, B, and C, and any product that is compatible with A is also compatible with B and is also compatible with C. If those are all equivalent, then the specifications are the same. They're referring to the same group of objects. But here's where it gets very weird and interesting. We saw this some at Schneider when we were there. Imagine you have specifications for a particular kind of miniature circuit breaker with a particular voltage and amperage and a few other characteristics. You might have three products, two of them from one company, one from another. The specs are slightly different, so you can't say the specs are identical, but they're different in ways that, again, are meant to deceive a little bit. They have this game where they change the operating temperature by a few degrees. They're just saying it used to, you say it will operate between, 30 degrees Fahrenheit and 130 degrees Fahrenheit. And if you change that to 31 and 129, it hasn't really changed anything. But they do that to disguise the fact that the product specifications are referring to the same kind of thing. So if you're a distributor, you want to know which ones are really interchangeable, because you will bid pricing like that. If you're a manufacturer, you probably consider them all different, unless maybe you're the manufacturer. You may, in some cases, literally make an identical product and only at the last minute put the different spec on it. So you may want to know that these are really the same. Then we have the case of documents. The question is, how close do two documents have to be to each other to be the same? Do they have to be absolutely identical? Do they have to be identically formatted? Do they, does formatting something constitute a difference? And should we have the relationship of one to the other? Are different versions of the same document considered different or the same? And then finally, transactions. In the world out there, there's a lot of infrastructure to make sure that transactions only get processed once. There's a lot of middleware to absolutely guarantee that a transaction goes from point A to point B and does not get processed twice. So, whenever you make an ATM withdrawal, that little transaction is zinging all over the place. And we hope that the withdrawal doesn't get processed twice, because then your bank account would be lower than it really is. And obviously it works, but there's a lot of middleware to make that work. But maybe the simpler thing is to be able to detect whether two transactions are really that arrive at different times are really in fact the same transaction. And a simplistic way of doing that would be if they came from the same account, same day, same ATM machine, same amount, it's almost enough to say, oh yeah, those are the same transaction. But the reason it isn't enough is because you could sit there and withdraw $100 and then couple of minutes later, withdraw another $100. Oh yeah, I need some more money. So we don't want to consider those two to be the same. But what people would typically do is take some posted date or something that, machine readable, distinct date, but that's just as likely to get false negatives. And it's possible that as the transaction got routed different ways or different times got associated with it. So that's probably overkill. Probably, the way to do something like that would be to say, what was the exact minute at the machine that you made the withdrawal, because it takes too long. Nobody can make the exact same withdrawal at the exact same minute. And, this happens. This is mostly a manual process right now. When you process an invoice, we really should just be able to have some kind of rule that says, have we seen this invoice before? And if we have, let's not do it again, or edit it if we have. I came across a handful of other examples of not doing this. Well, actually, the first one, very cool project that Mark Wallace did to try and figure out whether proposals and projects are really the same in the real world. What was happening was Small Business Innovation Research, SBIR, gives money to small companies to solve some interesting problem, and somebody will get $250,000 from a particular branch of, I don't know, Homeland Security or something to make a prototype of a quantum skateboard or some crazy thing. And then they get that money and they make the prototype and they show how it would work. But then they turn around and send the same proposal to another, the Navy or something. Oh, that sounds pretty good. Here's 250,000. Well, that's actually, you've broken a law there, because you've taken the same money. You've taken money twice to do the same project once, because you've already done it. And they build a very cool topic map based system to detect that. But that's kind of a rare edge case. I found somebody doing identity resolution to find whether two vacancies posted on job boards and stuff like that were really referring to the same job or a different job. It's a little tougher, and I'm not exactly sure why anybody would care, but maybe they were counting vacancies or something. And then a classic one we'll talk about a little bit more is people spend a lot of time trying to figure out whether visitors to the White House were the same person or different people. So going back to the original problem we put forward, once you get past the normalized literals, and you have two bags of strings, you're asking yourself, do these two URIs refer to the same thing or not? How do we go about that? And the first thing, of course, we're semanticists, so we had already done this in our heads, but I wanted to make it more explicit. Everything is going to have a type, it is going to have a type. Whereas a lot of times, machine learning and stuff like that, they don't care about types. It's all just strings and see what you can learn. In this case, we have types of entities. We know ahead of time that both these things are either buildings or people or organizations, and therefore that will lead us to different strategies. And then each of the literals has a type. We don't want to compare names to zip codes or anything crazy like that. Every once in a while, some things match that, maybe an employee ID matches a zip code. If it happens to be a 5-digit employee ID, but you don't want to count that as a match. The second thing that comes up a lot in the literature is something that they call blocking, which is really recognizing that if you had 100 million or 300 million entities and you try to compare every pairwise combination of them, it's just exhaustive for the computer. So how do you narrow it down? Interestingly, a lot of the strategies to narrow it down go overboard. If you're looking at buildings, and if you think that your zip code information is good, there's a data quality overlay on this thing, but if you think your zip code information is good, then don't go looking for 102 Main Street in every city in the country if you're just trying to compare it to 120 Main ST here in Fort Collins. You know, zip things that don't move a lot, like buildings. Zip might be a good blocking strategy, but terrorists is probably a terrible blocking strategy. So then the real key is you need some rules somewhere. You need to say, in my world, when I'm dealing with buildings, if the normalized address plus, I don't know, the owner's name or some combination of things are the same or sound similar or something like that, that's good enough. Or some other rules to say, if we know these things, we know they can't be the same. So this is the kind of the core of this. In a lot of systems, it's a probabilistic thing. So if you get certain level of match, you could say I'm 50% or 90% confident that these are one and the same. You want rules that describe things that increase the likelihood that two things are the same, and also rules that decrease. You know, so and for instance, you may have an algorithm that tells you these two patients are, you know, almost certainly the same person, but then you look at their blood types, and again, assuming you've got good provenance and quality in the blood types, and you realize they have different blood types. What we know about the real world is that one person can't have two blood types. So therefore, probably not the same person. The other thing, going back to that histogram idea, the histogram should not be the histogram of data you already know, because, you know, let's say you have a little tiny database and you have only one James Smith in there, and then you find something on the web for James Smith. You don't want to be duped into believing, since there's only one James Smith in my database, therefore I'm highly confident that that's the same. No, what you want is a histogram of the world. And sometimes you can have that. Like when we worked at LexisNexis, they have a database of every lawyer in the world, and they get them when they go into law school. So the odds of anybody being missing from that database are very slim. If they find a reference to a lawyer in a case report and they match it up against that database and they get a single match, you go, oh, very good chance that that is exactly the same person that they're referring to. If you get multiple matches, you may need more data from the context to, if you've got something ambiguous. And if you get no matches, you probably had too much data that you're trying to match to, and so pare it down a bit until you match. So it works if you have, you know, the entire universe of a population or something close to it. Or even in the case of people's names, we don't have to have them all in our database. If we just had a histogram, we knew which names are rare and which names are common. It would change things a lot for us. And like I was saying earlier, my wife has a quite a unique name. You can rely on that a lot more than James Smith out there. So now the question is, where do rules come from? And they come, I think, from three sources. Mostly they're just made up. You know, most domains have just decided, like healthcare, if your social security number and date of birth match, they go, okay, that's you, come on down. Other places, they have different sets of those, but a lot of companies just have something that they made up and they run with. The other place the rules come through is data scientists. They get lots and lots of examples and they create these things. Sometimes they call them match specs. Which things do you want to weigh more heavily, and you iterate over them and see how it goes. Or artificial intelligence is essentially creating these rules, but they're opaque. You don't actually necessarily know what the rules are. We're going to go through an example I found that was pretty unproductive, and I think it's why, on the flip side, why people want to use it, because it's fun and seems to produce results. But but in a lot of, there have been cases that have succeeded, but probably as many that haven't. So, this thing called District Labs Basics of Entity Resolution. I think they're really mostly trying to tell you how to use some Python packages, but what I think the whole tutorial revealed is how easily it is to get seduced by this technology and do things that don't make any sense. Say how there's a database, there's about 1 million people visited the White House from, 2006 to 2010. I forgot exactly when it was. And they have this log that has 29 columns. And that's what AI loves. Give me a flat record with lots of features and a training data set, a golden set, and I'll figure this stuff out. Here were the fields. Typical AI, let's just go for it. But a semanticist would look at this and go, hey, wait a minute. Almost all these things have little or nothing to do with somebody's identity. In other words, if the meeting room number or the callers, the person that authorized the call was different, does that mean the person visiting was a different person? If they visited a different person, it makes them different, or they visited the same person, that makes them the same. There's almost nothing here other than their name and their badge number, if they have a badge. Obviously, most people that visit the White House don't have a badge. If you have a badge, that's probably a pretty good one. But then what was even worse, when you think about it, how did they get their golden record? Because all they have is this data. So they had an Amazon Turk, and they just asked people if they thought 2 visits were the same person. But that's kind of ridiculous when you think about it. All it's going to do is find common misspelling. So the Amazon Turk would say, is Jim Smith the same as James Smith? And a lot of people would say, yeah. But you go, wait a minute. How about is James Smith the same as James Smith? When you think about it, you go, oh yeah, I have no idea. There's no way to know whether they're the same person. So knowing whether James Smith and James Smith are the same, if you can't figure that one out, then Jim Smith and James Smith, forget about it. And then they discovered they had John Doe and Ben Jealous. And they said these were aliases. It was hard to tell from the syntax of the sentence whether they meant they were aliases of each other or aliases, fake names. But, can you imagine if somebody said, oh, yeah, those are the same? No, they're not. There could be, thousands of real people that are calling themselves John Doe for this purpose. Okay, so, sorry, that was just an aside. Here's the question. Do we need ontological support for entity and identity resolution? And if so, what? I've divided this into 4 parts. I realize I've used it most of the time, but I'll get through this quickly and then ask the question. The first bit is normalizing our literals. So one question, hold your fire here for a second, is should we represent the result of this in the ontology, and should we do it in a standard way or in a different way per system? How do we want to indicate the quality of a given data attribute? Because we might want to factor that into our rules. Like I was saying earlier, if you can really rely on the quality of blood type being good, then that may change the value of your rule. And how and where should we put this histogram data I referred to? How it's essentially saying how good is a given attribute for a given population. The third one is how to represent a match spec that's somewhere behind this. Whoops, there's something saying for buildings, same normalized address, same zip equals 98%. It has to have a way to describe that. And then finally, the conclusion you come to is either that those 2 URIs refer to the same building, or they refer to a different building, or do we put another object in between them and say, here's how confident we are about this? And if so, is that weights on the edges, is that RDF star, or do we put another object in the middle? things like that. So I'm going to hit the summary, and then I'm going to turn my screen off. And we're just going to have a discussion for 10 minutes or however long people can stay. So just to recap, this is the act of determining whether two URIs refer to the same referent. That in our world, that's what it is. It's a whole bunch of cleanup and adding more data and taking rules and algorithms, AI if you must. And there are these things that we may or may not decide to have a common vocabulary to represent. And with that, how do I guess I don't need to stop sharing, but I'll just screen sharing. Stop. Yeah. Okay. Does anybody want to? Is there a hand raising device in this thing? I don't see it. But...
Yeah, I don't see it either.
We can always just use the Ethernet protocol.
Okay. Anybody have an opinion on this?
Product SKUs can get very gnarly. You get SKUs that are aggregates, you get SKUs that are configured.
Mm-hmm.
Sometimes the configured SKUs are you do the base SKU and then configuration becomes a SKU. Sometimes it doesn't. It's very, very fascinating.
Mm-hmm. And sometimes entity resolution is not establishing, and I kind of glazed over this, not establishing same as or different from, but part of, or, like in the organizational one or in the aggregate SKUs where they have kits, you could say, well, these three parts are part of this other SKU, which is really a kit. So sometimes it's not getting us to same as, but part of or something else.
You talked about concern. I mean, what was the last thing you mentioned? Confidence.
Yeah.
It seems to me that confidence is like provenance or ownership or any number of other things. It's a meta concern of people. So if we have confidence, it's a general solution. But we know how hard it is to navigate from tuples to reified tuples and back and all that jazz.
Mm-hmm.
So I'd like to solve it with a general solution like that. It would need some digging into it to see, well, can we do better than standard RDF reification? We probably can at this point. But yeah, I mean, anything, it ain't necessarily so. We have to.
Hey, John,
there is some very interesting predicate logic that variant that deals in evidence and confidence. How you should change your confidence on the basis of positive evidence and negative evidence. It's very intuitive that if you see every time you see a white swan, you become more confident that all swans are white. Whereas really what you have to do is to look for a non-black, non-swan is what predicate logic tells us. That's the only thing that truly proves that all swans are white. And however, by the use of this logic, we can say, okay, our confidence rises every time we see a white swan, and that's what really matters. After all, we do not have an infinite amount of time to make decisions, nor do we have an infinite amount of information to make them on. And this logic, it's called NARS, is very well equipped to deal with that sort of stuff.
And John, I wanted to ask you, when you were at Lexus, did you ever get exposed to what they called match specs, the way they used them there?
I did not.
Because
I was basically concerned with document schemas.
Oh, yeah. Okay. Because they were pretty sophisticated in that, but I was only tangentially involved with it.
Mm-hmm.
So I have just a data point to add from the military intelligence domain, where entity resolution was a very critical thing when we were trying to see if multiple documents that you received as intelligence dispatches referred to the same person. And other than doing blocking by the name Soundex or geolocation or organizational membership, et cetera, and so forth, we never actually automatically asserted identity. we asserted a probable identity, at which point of time the probable identity was submitted as a candidate to a human resolver to either confirm or deny, at which point of time we would record either the confirmation, which would be an effective entity merge, or a denial, which would then become an effective recorded disjoint, which would keep those two entities from being considered as identical again, so they wouldn't come up in subsequent searches. And the biggest thing is we could set the thresholding as to what level of similarities the two entities need to have in order to be presented as a candidate and take up somebody's time. Obviously, that's not feasible in a high volume thing like transactions, but in a high confidence environment like intelligence, you cannot assert identity automatically. That's just that you can never have that much precision.
Yeah, but what do you suppose the analysts were supplying that the algorithm didn't have? In other words, they have to be doing more than this mechanical Turk example I had, because, you know, were they
they could look at the supporting documents. Every single fact that we had about an entity had provenance to source documents. The source documents were processed by NLP, so sometimes facts extracted from them were not necessarily very precise. Because you can have second-order resolutions of, do these similar named organizations that they refer to, are those actually the same organization? So that there's a lot of further digging that you can do. And you can say, well, they are, you know, known movements and presence in various, there's secondary and tertiary factors that are concerned that are too big of a problem space for an automated process to dig through due to the same sort of combinatorial explosion that you alluded to. But on a case-by-case basis, an analyst can very quickly discard some false positives.
The other thing you have to have, though, in that situation, Boris, is a full track of all the measures that you took to all of the same as and the consequential things that you did, because sometime later on, your whole logical progression might be defeased by some other information, and you have to roll back everything.
Yes, and we actually would record about every statement. We would record assertions of the form of supported by so-and-so and negated by so-and-so. So sources, either automated sources or documents or analysts could say, I think this fact is true, or I think this fact is false, which means that subsequent inference based on those facts would become an aggregate of those confidence levels. But we would be able to retract a whole bunch of things as well and say, no, these things are no longer true, or we don't think they're true. And because of the very extensive provenance that was kept, even an entity merge, once performed, could be unrolled completely if a fact came in later on. So provenance really plays a lot into it if you want to be able to prove your decisions later and possibly walk them back.
Yeah. Yeah, I just noticed we're at the top of the hour. Some people may have to drop off, but I can hang for a bit if anybody wants to continue on this thread.
I just had a quick
Dave,
thought.
I was going to say, when I saw this topic and the role of ontology for entity and identity resolution, I assume you're going to talk heavily about linked data, right? Because this is what where I see, you know, we can tell a really good story about leveraging linked data, right? Like if I have two entities, or I have a newspaper article that mentions John Smith, and it mentions that he lives in Hackensack, New Jersey, and I have something in my database that says that he's from the Northeast. That John Smith lives in the northeastern United States. That linked data point gives me, you know, some kind of utility. Or if I know he works for a particular company, and the newspaper article mentions that another subsidiary of that company or something like that, right? All these kinds of things. The linked data just is. So that's where when I tell the story about ontology and entity resolution, I'm often saying, just the fact that we're embedding it in this big context of linked, a network of linked data and the fact that we know something about it, right? Like that we can do a little bit of parted reasoning where appropriate and that kind of thing is a great boon for doing some of this kind of resolution. And I think that kind of gets to, you know, that would kind of cash out in terms of the rules, right? You obviously have to have some kind of rules for that, but I'm just saying the that semantic network gives you a rich framework to deploy those rules in.
Yeah, I kind of glossed over the whole idea of augmenting data, but obviously linked data is the classic way to augment it.
If you notice, when a newspaper prints the name of an accused criminal, they often include a middle name for that very reason, to increase confidence in entity resolution.
Yeah.
Quick thought, Dave. I thought very nice presentation, by the way. Very interesting way of looking at things. Especially the fact that there's many different kinds of things that need to be resolved. I've mostly thought of this in terms of people. Just that's the main thing that people worry about, so to speak. But I think the possible scope for ontology is when you have the multiple kinds of things, and each one has its own set of rules. And the way that you could snap, you know, the match spec could all be done using ontological links, kind of like what Mike Poole was hinting at. So it does seem like there's some overlap there. I only have a little bit familiar with one company who does this, and I think that they're mostly focused on people.
Yeah.
And I'm sure they've written a bunch of code and they use AI and all this stuff, but I don't know whether you could augment what they do and grow it to do a different range of things, organizations, and whether they have nice metadata already and they could just be happy, or whether ontological stuff might help them. I don't know. That's an interesting question.
Yeah, the thing that's in my head at the moment, and then partly why I wanted to talk about it, is it's one possibility that everything I talk about right now should be over in a architectural ontology, you know, because you have to implement this resolution in an architecture somewhere. It isn't, you can't just run the reasoner, I don't think. So then the question becomes, yeah, but if we're going to describe these rules and the normalized attributes and the confidence intervals and all those things, maybe we should just define that once and put it in GIST. But I actually haven't come down one way or the other on that yet. It's kind of why I wanted to talk about it.
I think the safer approach would be to start off with it as an GIST adjunct or add-on. You know, like we're doing with GIST software at the moment, and eventually determine whether or not it belongs in the main GIST core. But I do think, you know, data centrically, we do need some description of it.
Yep.
It also has to be driven by a use case. Most of our clients, it hasn't arisen for the most part with any of our clients in terms of actually needing an ontology to do something with this. So,
well, it's starting to show up a lot now. We're going to get it in the fixed asset project that we're looking at, because some of those examples, they've got tags, they've got serial numbers, they've got and they've got data attached to all these things, and they don't realize, oh, it's actually the same heat exchanger, you know, simple stuff like that.
Fair enough. Yep.
And there's another one that's coming up already. But, you know, this stuff, it's there more often than you think. We've sort of gotten a free ride on curated data, but yeah, we got to start thinking about this.
But in terms of, you know, when you were talking about the judgment criteria, how many matching data things do we need before we say these two people are the same? So that can vary a lot, but it seems to me like the geographical stuff, which is very, very common, but it should be the rules should be relatively stable from one domain to another. And so, you know, that might be good place to start, and and have, at least from a semantic arts standpoint, a set of approaches that when we go to a client, we can say, oh well, if you're having to deal with with geodata and you want to bring in linked data or something, here's a set of rules that we recommend.
Yeah, and to Michael's point, I mean, you've got that use case right now.
Yes, exactly. That's why it's on.
Right.
So I find that I think Michael brought this up, right? The not just thinking about people, but the other objects that you might want to do identity resolution on. Document stands out to me as sort of a different from the rest. At least representationally, often when we talk about documents, we're sort of ambiguous between talking about the document itself and sort of the conceptual content that it represents, right? So if I want to see what the two things are, my dissertation, I care more about whether the ideas reflected are basically the same, and so leading spaces or whatever are different. But maybe something like receipts, we might actually care very much about the particular piece of paper or something. But in that case, right, we have this, because there's this conceptual content, you have like this intermediary that you can use, right, where you can say this thing and this thing aren't the same, but they both they are both refer back or represent this conceptual content.
Right.
Too much about it, but there might be sort of a similar move that we can make in some other cases, right, where like you were saying, it's not all about same as that we're concluding to identity, going to be part of these other sorts of things, but maybe there are more cases that are structurally similar to this conceptual content, or maybe they're very different. I should be thinking about them differently.
Right. Yeah.
I am kind of interested more from the provenance part, like especially in rule-based system. I'm dealing with like little sentences or like just keywords, so I can't apply any AI approach that would, define the verb, a noun, and everything. So I have to use regular expressions, and you start building your regular expressions, so that you start doing some matching. And I think it would be great to be able to store which regular expression actually match which part. Because afterwards, when you're going through the result, you're going to say, oh, this is wrong, this is wrong, this is good, this is wrong. But for all the wrong part, if afterwards you can have a broad view of which rule actually match the wrong parts, then you can say like, oh, that's why it's wrong, or this rule, I should change this rule or whatever. So the provenance part is pretty interesting. And I think I'm not sure I followed everything that Boris said, but I think it was kind of the idea, no?
Mm-hmm. Yeah, in some ways, well, there's two aspects to provenance. One, provenance is sort of a proxy for quality. A lot of times you say, if it came from here, or if it came from this algorithm that I've trusted and tested and used 1,000 times, I have higher confidence. If it came from some shady other place or some brand new algorithm, maybe not so much. But the other one, the one you're talking about, is when you detect that something went wrong, you want to be able to trace back, what step in the chain actually caused the problem.
It's exactly, especially, I'm taking the example of regular expression. It could match a lot of things. When you define a regular expression, you are designing it to match something specific, but it could match a lot of other things. And as you're building your system, you're going to have more and more and more regular expression. And at the end, it's very hard to have a broad view of why did it match this part and why is it wrong.
Right.
It's more in a tool so you can, enhance over time and help the human enhance over time.
The other thing that you might want to consider is this whole histogram idea I had. Because imagine if you had WordNet and had a histogram of all the word senses of every word, and took, these keywords. You think if you bounce it up against that, if there's only one word sense that matches your literal, you'd say, oh, pretty good chance that's what they were talking about. But if you get ambiguous words, you'd say, oh, there's a pretty low chance that, or I'm just guessing that what they, this context.
I see. Well, my problem is that it's not exactly words, like standards and stuff like this. I can't use word, but I see your point.
Yeah. Anyone else? I think I may take Dan's advice and create a little sub-gist of at least some of these concepts. Part of me thinks that when somebody enters their address, that you should store it as they entered it, or enters their name, or enters whatever it is you were using, and then you normalize it, and somewhere else, or a different predicate or something, we say, oh, here's the normalized version of that. It doesn't sound like we should always wipe out the original thing they gave us, but have some way of knowing, here's the normalized one.
At MD Anderson, that's what we do with our patient master. We contract with a third party for our master data management address validation. So one of the things we haven't quite modeled it yet, but we've had a lot of discussions about breaking out the address from the person and truly modeling the separate. Well, we haven't quite gotten that far, partially because the underlying data doesn't do that. But certainly we send that off, we bring it back, we have the original data as it was provided from the source system, and then we have this corrected data. There's a lot of legal issues with that. Sometimes these address verification or validation services will provide you with a different address, and people don't always want their medical information being sent to an address where it might be viewed by people who don't want to, the patient doesn't want to allow that to happen. So there's some there's some gotchas around, seems like everything, but certainly considerations that need to be taken into account.
Comment about what you just said, Jim, moving toward separating the address from the person. It's interesting when you go to Google Maps or something similar, you type in an address and it says, did you mean this? And it's converting it to some standardized representation. So it's representing some internal thing that it knows is a single thing, and it has its own standardized way of representing it. I just wonder how you can get hold of these things. Post office probably has it. Maybe there's some standard database. I don't know.
Well, what this third-party service does is it operates a lot, at least within North America, off of the USPS standards, so it derives a lot from that. Takes into account some, some other services that may, triangulate mailings that are available. Some kind of for fee, some sort of subscription services that are out there. So they leverage that. They leverage a number of sources and they try to find the best one. They even have this. So we use Melissa data. They even have this impersonator, where if you provide the name and either a phone number or an email address, they'll try to triangulate that person to see if they live at that address. So there are different levels of granularity that you can go, and that's kind of one of the things about this identity resolution. It's kind of, it has to do with the level of granularity that you're looking to go down to.
Right.
Sometimes they'll make corrections, like for an apartment building, they'll find the physical location, but it doesn't necessarily mean it's a deliverable address if they don't have the unit number, for example. So there are a number of, either errors or error messages or, some sort of warnings that are provided as part of that service.
Yeah. And, you know, splitting out the addresses, I think, is essential for, there's a whole bunch of use cases that start making sense once you split it out. Because really, address is not an attribute of a person. It's a relationship of a person to something. And so this may be where I reside. This address is where I live. This address is where I want you to send my bills. This address is where I want you to send my subpoenas. You know, those are relationships of addresses to people, and that they're temporal and all that kind of stuff.
That's right.
Yeah, we got into that in the state of Washington. They wanted to have a website where people, like it was called One Washington or something like that, where a business could go in and, quote, change their address. The first thing, the one agency we were in, we found at least 100 addresses in various systems. And if you just change it, does it really going to change all those 100? No, actually, because some of them are historical, some of them and then for different purposes and all. No, it was like a bad idea.
Yeah, and you know, that the discussion about provenance is another aspect that we've been looking at. You know, from our perspective, the provenance of the information can have a direct impact on the quality, or at least the perceived quality, because if we have for example, a blood pressure, depending on who reported it, if it's from a clinician, that's one thing. If it's from a patient reported blood pressure through some, you know, some device that they have at home, that, you know, that may mean something completely different. Of course, if it's a machine, you know, you could detect that there's issues with the machine. If all of a sudden you start getting erroneous information, or it's consistently off. So we're trying to take a look at that also.
Yeah. Okay, last call for thoughts on this. Well, excellent. Thanks.
Thanks a lot, Dave.
You bet. You bet. My pleasure. Thanks for the feedback. And
Thank you.
I don't know how to turn this thing off.